Hello everyone, I'm Salar and this is part A from my tutorial for writing a real-time operating system. We are still talking about prerequisites for our tutorial, and we got familiar with Linux operating system, and now we keep talking about GCC and GCC programming. Okay, let's do open a terminal. In the last part 7, we got familiar with compiling a step, for example, preprocessing, compiling, assembling, linking, and creating an executable file. Now, let's create a simple project another time. Create a directory. CD to test. And let's create a header file. For example, header.h. And in that, let's create a simple function. For example, a function for multiplying. Int mul. This function multiply two number. Int a and int b. Okay, and it return a multiplied by b. Okay, it's a simple function. Let's just save it and create a main file. And use this function in main file. First, include standard after that include my header file in quoted mode because it's in current directory, header.h, and in that create a main file, and the main file print a function. For example, 6 multiply by 2 equal with an integer number, and the integer number is multiply of 6 and 2. Okay, it's a simple function. Let's compile that. GCC main.c out file. Sorry. Oh, sorry. Let's open that. Multiply two arguments. And another time compile that. So if I run out, 6 multiplied by 2 is 12. Let's do cat my header file. If I want to give this header file to another programmers, those programmers that have this header file can read the body of function. How can I close my source? Okay, how can I close my source? Assume that I don't want to give my code to another programmers and I want to close my source. How can I close my source in programming? It's so easy. Let's do another time nano header file and remove and delete the body of function. Okay, and put just the definition of function in header file. Okay, remove body of function, save it, and create, for example, a file for multiplying two numbers. And first include the header file and in this file write the declaration of function and body of function. Okay, int multiply to integer number and here he multiply by b. Okay. Here you can see it's so easy function, but I want to say the concept of issue and the concept of our work. For example, you can have a so complicated function and you want to close your source. This is the way. Let's save that and convert the multiply.c mul.c to an object file. Okay, convert it to an object file. GCC-c to create an object file. Multiply.c-o2, for example, multiply.o. Okay, so I have an object file from my file, okay, from my code. And now I can compile my program with object file. Okay, with object file. Now you can see I compile my code with object file, and if I give this object file to another programmers, they can't read the code, they can't read the content and body of my function, and just they can see the machine code and the content of object file, and they can't see the body of function in C programming. They can just see this object codes, okay, these object codes, and they don't access to body of function anymore. Another time, if I compile my project with object file, it's like compile my project with source file. I can compile my function, my code with object file, and if I run out, 6 multiplied by 2 is 12. So let's to add another object file to my project. For example, for dividing, nano file for dividing, divide.c, and here the function, the body and arguments, int a and int b, and return a multiplied by b. Okay, and let's do put the definition of function in a header file, nano header file, function for dividing, int a and int b. Okay, save that. Okay, let's create an object file from my divide.c file. Divide.c file. GCC-c for creating object file. Divide.c. Output name is div.o. And I have an object file from multiply, an object file from divide. Okay, let's do change the main.c file. And put another printf, and here, for example, 6 divided by 2 equal to an integer number, and a new line, and the result is divide 6 by 2. Okay, let's save it. And another time, compile my code with these two object files, mul.o and div.o. GCC main.c. I need two library, mul.o and div.o and the out file. Okay. Sorry. In header file line 2. Let's do in header file. Sorry. Here is. It should be. Come. Save it and another time compile my code. So another time, if I run my code, 6 multiplied by 2 is 12 and 6 divided by 2 is 3. My code is through, and I just give object file to GCC. Okay, and I can just give my object file, not body of my function, and in this way I can close my source and create an object file for compiling is not just for closing source. When you create an object file from your libraries, when you want to compile your program for example main.c, you do not need another time compile, for example multiply.c or divide.c. okay, you can put the compiled code and you can save your processing power. Okay, one time you create an object file and other times you use that for creating an output file. Okay, but creating an object file is a good way and is a way for closing your source, and this way you can close your source. If you want to give your source to another programmers and you want to write an open source program, you can give your C file to another programmers, or you can write all of your code in header file. Okay, in this two way, write up your code to header file or give your C file to other programmers. You can have an open source project in this way. But if you want to close your source, you can create an object file and give it to another programmers. Another programmers just can use your code and they can't change your code and they don't access to body of your functions. Okay, now assume that I want to create a lot of object files, for example for multiply, divide, sine function, cosine function, tangent, and I want to have a lot of object file for math functions. Okay, I can write all of my code in just one C file. For example, let's do nano mul.c. I can write all of my code in just one C file. For example, assume that the name of this file is mymath.c, and I can write all of my function to this file. But writing your code in more than one file, for example splitting your function to some file, for example multiply.c, divide.c, and in this way you can order your project. Okay, and in this way you have better order in your project. And if you write all of your code in just one C file, you have a big library and big C file, and if you want to change a part of that, you have to another time compile all of that your file. But if you want to write your code separately in some files, for example, like here mul, divide, or another functions, if you want, for example, to change one of your library, you can't just change those files, change that file and recompile that. Okay, but this may have some problems. For example, assume that you want write a software that, and in that software you need a lot of mathematical functions, and in compiling time you should write main.c, for example, mul.o, div.o, for example, sine.o or cosine.o, and a lot of function, and it makes your compiling very hard, because you have to write a lot of libraries. Okay, you have to write a lot of libraries. There is a good way to create archive from libraries, create archive and package from libraries, and it can make our work so easy. You have all of your objects separately, and when you want to add these objects and these libraries to your project, you can just write, for example, in an archive file. Okay, and you do not need to write all of your object files. Let's create an archive from mul.o, multiply.o, and divide.o. AR is a tools from GNU, from GCC. Okay, and it can create archive from your object files, and the option is -r to put or replace an object file to archived file. Okay, I want to put mul.o and div.o, and after R I should write the name of my archive. This time, for example, my math.a. should put .a for extension. Okay, and if I press enter, now I have an archive file from my object file. If I want to see the content of archive file, command is ar-t. Okay, and my math. The content of my math, contents of my math is multiply.o and divide.o. So now, if I want to recompile my main project, GCC main.c, this time I do not need put my object files another time, for example, mul.o or another object files. I can just write my math.a, my archived file. Okay, after that write it in output file, press enter, plus, and I have an output file. And if I want that, 6 multiplied by 2 is 12, and 6 divided by 2 is 3. This way, using archived file, make my compiling very easier than before. Okay, in programming, these files known as static libraries. Okay, static libraries. My math.a is a static library. Okay, but there is important point here. You should write your code, your file before your library. Okay, if you, for example, write it main.c here, it's a wrong way. Okay, you should write main.c before my math.a, because in compiling process, tools first examine main.c, and it finds that main.c need two object files, for example multiply and divide. After that it can examine my math.a and link multiply.o and divide.o from my static library to output file. Okay, if you write main.c after your library, first in compiling process, compiler and linker examine my math, and they don't know that main.c need a multiply and divide. Okay, so you should write your static library after your file, but it's not important when you want to write your object file. You can write your object file before main.c, for example mul.o and div.o. It's true, and you can create your output file. But when you want to use your archive file and your static library, you should write it after your code. Okay, and for example, assume that your main file just need multiply. Linker just add multiply to your code and do not add a divide to your code. Okay, the linker add those files that your code needs. Okay, and it can save your RAM, and it can decrease the size of your file. Another time run that out, and it's the output. Okay, in this time I have for example some or one static library, and I want to put my static library in a subdirectory like header file. I put my header file in a subdirectory, and with -i, or for example header, I can give the address of subdirectory to compiler. So how can I put my libraries in subdirectories? Let's create a subdirectory, for example subdirectory for lib, my libraries. Okay, and let's move my math to lib. Okay, let's remove multiply.o and divide.o. Okay. I have a lib directory, subdirectory, and in lib I have my static library. So how can I give the address of my static library to GCC? Let's recompile my code. GCC main. Let's go back to per directory. GCC main. After that, the address of my subdirectory. For example, in here -l. -l is the option for give the address of subdirectories of your library to compiler. Lib, and after that name of my library .a output file to out. Okay, press enter. It's wrong. It's wrong way. You can't give the name of your static library in this way. And there is a special way to give the name of your library when you add the subdirectory of your library with dash capital A. Okay, when you give the address of your subdirectories for your library with this way dash capital A and the name of your subdirectory, you should put the name of your library in a special way. And what's the way? Let's describe it here. Here, the name of your subdirectory is, for example, lib, and give it to compiler by -l and lib. Okay, when I want to put my static library or my libraries to a subdirectory, I should name and I should rename my library, and it's the standard of naming first lib, after that name of your directory. Okay, I should rename my static library to this name, a prefix lib, and after that name of your library. And when you want to give this library to your compiler and to GCC, it's the way. GCC, for example, main.c-l, for example, lib. After that, it's the standard -l and this part of your name. Okay, and this part of your name here, my mass without .a, and after that -o2 output file. Okay, so first you should rename your library like here, lib, prefix lib, first of your library name, and give the name of your subdirectories by -capital L. After that, in this way, write the name of your library. Okay, this is the way. Let's do that. First, cd to lib and rename math.a to lib my math.a. Okay, and now I have lib my math.a. Back to test directory, and another time GCC main.c -capital A for address of subdirectory lib. After that -l my math. Okay, just my math, no further math, my math.a or l lib. Okay, just this green part. Okay, just this green part. After that, OT2 output. If I press enter, now my code is compiled and run that. Here is the output. Okay, this is the way. First, create a subdirectory, for example here lib, rename your static library to this model, to this way, and write your subdirectory of libraries with -capital A. After that, in this way, write name of your library. Okay, it's not like header file. In header file, we just write dash, for example, I. In GCC, and GCC find the header files and add it to your project. But in library, the story is different. Okay, so I said that, for example, here, my math.a is archived from my object file and it's static library. But there is another term in GCC programming and it's shared library. We don't need shared library in writing a program for microcontroller. So I don't spend my time on shared library, and you can study for shared library on internet, and there is a lot of good textbook. For example, here is a very good book, computer, I think, computer programming, programmer perspective. Programmer perspective. Sorry, computer programming. Computer programming, programmer perspective. Okay. It's a very nice book and very good book. And it has a lot of information for compiling and about Linux operating system. And it completely describes the static library, shared library, linking process, and what linkers do for link your object file to each other. There is some step in linking, for example, resolution, relocation, and what's dynamic linking, and a lot of information about linking and running your program and loading your program in your computer. And it's a very good textbook. You can provide that and read that if you want to find a lot of and more information about compiling process and writing program. But in this tutorial, I just spend my time on static library, because in microcontroller programming, I just need static libraries and I don't need shared libraries and shared objects. Okay, in this part, we've gotten familiar with static libraries, archived object files, and how can I close my source, or how can I compile my code with object files, and how can I create a subdirectory from our libraries, and how can I give the name of my libraries to compiler in this way. Okay, and it's enough for today. And I start talking about another tools in next part. Thank you and see you soon.